Hello and welcome back, everyone. I hope you enjoyed the break. Checked out the sponsors tables, the virtual sponsors tables with virtual flyers and all that kind of stuff. And maybe also enjoyed the hallway track a little bit, chatting to some friends that we all haven't seen in a long time. For the next talk, I'm very happy to announce Alex. Alex is going to talk about he's going to talk about Firetomic. And I think no one really knows what that is, but that's what I'm so excited about. So last time at clojureD, I think Alex already presented something on using Firebase, which is a fantastic database for like early stage development. And today he's gonna like connect the dots a little bit more and connect that to stuff like Datahike, which I think is also something really interesting that we've been seeing in the last while. And there is these really interesting developments around Datomic style databases, but making them distributed, making them more easily accessible. And I'm really interested to see what Alex has to show there. I'm also working with Firebase myself, so this is really interesting to me personally as well. And I'm really excited to see it. Please give it up for Alex. As usual, post your questions in Slack or GatherTown. And I'm looking forward to asking and discussing your questions later after the talk. Please enjoy.
Hello, I'm Alex. It's good to be here with you today. I'm super excited to share what I've been working on for the last few years. Thank you for having me back at clojureD, and I hope you're all well. A little bit about me. I work as head of design at Bank, looking after a team of 100 or so, a mixture of engineers, designers, and front-end devs. A great bunch of people. But when the moon comes out, I get this uncontrollable urge to write Clojure, and that is what has brought me before you today. So last time we spoke, I made a promise, and a man's word is his bond. And that promise was to give you Datomic on Firebase. But before we see how that went, we need to go back to the beginning of the Firebase story. So after varsity, during varsity as well, I was, young dev, enthusiastic to get involved with, a bunch of startups, and I had this choice before me. Coming from a Node.js background, do I want to go with Firebase or do I want to go with Parse? And two roads diverged in a wood, and I took the one less traveled by, and that has made all the difference. And it also helped that Google bought Firebase and they got tons of cash, but it hits true to the initial spirit. So I've used Firebase for years, and they've never failed me. I may have failed them by deleting some things in production, but that's my bad. And then a few years later, I discovered Clojure and immutability and Datomic, and it was marvelous. And I wanted to get started right away, prototype things, build things, and then I saw the price. I think this is the current price. Back then it was a bit more expensive. But I've worked in marketing, and I know what as low as means. And what it means is not $1 a day. And then on top of that, it's on AWS. Now, let's be real. No one, maybe even no one, one person knows how AWS pricing works. Probably the person that wrote that calculator. Everyone else just waits for the bill. And, being a student, can't afford to wait for the bill. You gotta know. And so the perfect storm occurred. I'd come back from clojureD, my last trip just before all the lockdown happened. Being an introvert, and then lockdown. No one being able to come visit me, disturb me, go for drinks, go for a movie or anything like that, right? So it was amazing. I could pursue the Firetomic dream with extreme passion. And so this brings us to part one, the scars and bad ideas. Starting Firebase, obviously, and DataScript. So I started with the first DataScript because it was apparent to me that there was no way I could replicate Datalog or a Datalog query engine. So I figured, let me find someone who's got part of the way there. And I found DataScript by Tonsky, and it was pretty neat. And I was reading through the docs, and I found this cool function called listen. It allowed you to trigger a callback every time a transaction happens in the DB. And so I figured transact on the data log store, send the transaction to Firebase, and then when you reboot your application, you stream them all back from Firebase, and you rebuild your DB. I mean, looking back, it probably isn't the best idea because you pay the penalty of all that insertion every time your machine starts or your server, which is not ideal. But anyway, that's what we did. But then I also realized I needed a way to ensure that the data was written to Firebase in the order it was transacted, and it was read back. It was read back and processed in that same order. And Firebase being JSON, a JSON store, JSON can be a bit dodgy. So I figured I need something to stream, like Kafka. But Kafka, it ain't free and it's admin. So I figured, let me just build Kafka on Firebase. So I got myself the Kafka book, read through it, get a good understanding of Kafka, and then I found a Clojure library called Kinski, which basically is a wrapper around Kafka. And I figured if I model Firestream after Kinski, if my applications outgrow Firestream, just swap the backend and it connects to Kafka instead of Firestream. So I was like, aces. We're good to go. But what I realized was that the performance just wasn't what it needed to be, right? When I was trying to keep up with the writes, it just was dying out. So I figured, let me use a queue locally on disk to make sure I capture the transactions at the rate happening, and then write them one by one to Firebase. Then I realized one by one wouldn't solve the problem, so I started batching them to Firebase. So that was really awesome. Then and then I could actually now control it, and since it was batches, it was happening much faster. And then I wanted to make sure that if the server goes down while these batches are going, could we recover when it boots up again, would it read from the disk and continue where it left off? So put together 10,000 or so transactions, run them, and while it was running, I'll kill the process, then reboot to see if it was working and stuff like that. And here's the thing, it didn't work out ideally, but it did, with certain configurations, reboot and read from disk and send it to Firebase. But here was the problem, right? In all of this testing, I was sending heaps and heaps of data to Firebase. And yes, Firebase itself is not free forever. Within reasonable limits, it's free. But when you're just pumping data in, it's not. And I was easily doing, over a gig, maybe 3 gigs an hour. So, yeah, it set my wallet on fire. In my quest to save $1 a day, I ended up spending way more. And also my hard drive started to get full, and my machine was getting slow, and I couldn't understand why. Eventually it dawned on me that all these temporary files from the queue were just stacking up. But it was a lesson, right? So I learned, I learned some lessons, but we got some good out of it. We got Fire, which is a REST client for Firebase. Very bare bones, just HTTP kit, amazing, if I can say so myself. And with it, I built a library to load the credentials for Firebase from environment variable, because for some obscene reason, Google's obsessed with giving you a JSON file, and I was like, no. And the libraries load the JSON file from disk. It's like, no thanks. So that was pretty cool. And then Firestream, right? So now I have my transactions and my streaming ability, and I've used Firestream in other places, and it's pretty neat. I hope one day I'll have an application at scale enough to need to port to Kafka, and then we can see if my theory holds out. So this brings me to part 2, right? So one thing I realized in this first part of this journey was that the parts that had the most drama were the ones where I went out on my own. Right? When I looked at worked with Tomsky's staff data script, there's no drama, So I figured stand on the shoulders of giants and you'll go further. So and then soon after that, actually I came across Datahike, which is a data log database by the folks at Lambda Forge. A really great bunch of people who really helped me on this journey. So I went to the repo and it seemed pretty neat. And I didn't do the README. I went straight to the source code, and I saw two files that actually jumped out at me: connector and store. And I figured if I could change the connector or change the store, I could probably redirect Datahike to Firebase. And looking through it, two namespaces jumped out at me: Bootstrap, because I have flashbacks from the time every site was built in Bootstrap, and every single library was in Bootstrap. But I figured that probably was in the same context. And the other one was konserve. It's interesting. So I checked out this konserve thing. Now, konserve is great, but I wasn't about to read this README. So I scrolled down and I saw something interesting. Clutch, right? Konserve Clutch, which is for CouchDB. And I remember looking at CouchDB back in the day when I was trying to see, do I want, and there's a whole discussion of Google buying Firebase. I was okay, I maybe need a backup, something similar to Firebase. And I remember CouchDB was very close in feel, being a JSON store as well. So I figured if konserve can connect to Couch, there's nothing stopping it from connecting to Firebase, right? And so I built a quick and dirty first cut, and it worked. There were some rough edges, and all the tests went passing. So I reached out to Christian from Lambda Forge. A lot of the stuff, from konserve and Datahike is his work. And the first thing he did was burst my bubble. He told me I'd used the older version of the protocol, which was basically deprecated. And so he took me through version 0.6. And version 0.6 actually was pretty neat because it added an ability to write metadata to the store, which meant that you could actually have a garbage collector. But basically, in short, konserve is a protocol that turns any underlying store into a key value store that can be interacted with asynchronously. Right, so the protocol is it's more or less straightforward. It's pretty straightforward. But the really nice thing about it is its interface is like that of a plain Clojure map, which makes it really easy to reason about, right? And it fits within our mental paradigm of Clojure developers. And it's also built with scalability in mind. So with this new thing, I started working on it, and the question became, how do I connect this to my store? And this basically is the let's call it the constructor of the konserve store, and it basically has a root. So this is basically aligned to Firebase. Right? So JSON store uses a path, so the root is a path, and the DB can be null because we can pull that from the Google credentials, and then we have various serializers, right? And the compressor and encryptor. And these were added in version 0.6, right? So now we actually have a way to compress the data and an encryptor, and then the read handlers and write handlers are basically ways to write custom data types, right? So when you read back, you use your read handler to deserialize your custom type. Yeah, and obviously you want to have reasonable defaults so that the end user doesn't have to think about all the drama. And because Firebase is basically a string store, we actually want to compress all the data. So by default, we use the LZ4 compressor. Anyway, so I did the first cut and it worked pretty nicely. And you can even see there's the metadata, right, when it was written, and when we discussing this, and I was chatting to Christian about his first attempt, it dawned on me that I had taken certain decisions. So for example, when it's the normal Eden, I would stringify it, use a string serializer, and just tag it as type string. When it was binary string, I would base64 it, load it, and put the type as binary. But that was decisions I made. If someone came a while later and changed it to be more efficient, or changed how it was laid out in Firebase, we could have the situation where one version and another could be completely incompatible, and there'd be no way to get data already written out of the store. So we discussed this for a while, and with the folks at Lambda Forge, came up with almost a way to standardize how the data is stored in the actual backing store. Because the protocol speaks to how you interact with the store and how you interact with the application, but the part that was missing was how you actually interact with the store. So the first thing was the store layout. So if you think about a JSON store, you can have different keys, and you can actually put your metadata and your data in separate keys, or let's call them subkeys, right? And then we want to also make sure that we state what serializer has been used, because when the new version, the new application reads the data out, it has no way of knowing how the data has been stored. So another bit to specify the serializer. At the moment, there's a string serializer and precedent serializer, right? And then, it would be really cool if we had a nippy serializer. So if someone out there, if you're keen, you could give it a shot. And then we also want to have know what compressor we're using, right? So there's at the moment there's only really one, so null compressor means no compression, and then lempels have the LZ4 compressor. At the moment, we don't have an encryptor, but down the line we want to be able to encrypt data, which would be really, really neat, because you could actually have multi-tenant things in a secure way. Yeah, so that would be the split layout, right? So if you think about split layout, put us after we serialize it, compress it, encrypt it, and that's metadata, and the same thing for the actual value of the data itself. Now, there's also the case where a store doesn't have the ability for subkeys, right? So if you think about disk, the file is a sequential piece of data. So in that case, we have the linear layout where we have the header bytes, those four there. Then we do need to have a bit of data to say how big the metadata is, because when garbage collector is running, and you pull metadata, you want to only pull the metadata, not the entire file. So with the linear layout, it's important to specify where the metadata ends, right? And so that becomes a linear layout. Obviously in the case of Firebase, we can't use the linear layout because you can't read part of a JSON file, the JSON key. You have to read the whole thing, right? So in that case, the split layout makes sense for something that's a JSON store. So let's we've alluded to it, but maybe we can talk now through very concretely an example of how konserve actually works. So let's say we have a fact we want to persist. Like Sandra is awesome for bringing us all here for clojureD. So we first hash the key, right? And this means that it can be easily used across stores because it's a simple string, no drama, and the length is known. And then we add metadata, and then we also have original data, right? And then that just brings us to the next step, and that's where we serialize the metadata and serialize the actual data, and then we compress them, and then, sorry, not compress. We actually after serializing we compress, and here it's important to note that when you're implementing a store, you always want to compress before you encrypt, because your compression looks for patterns in the data, but when you encrypt, you add entropy, and then those patterns are lost, so your compression is basically useless. So we compress and then we encrypt. Then after we've done all of that, serialized, compressed, encrypted, we want to add the header bits that correspond to how we stored it. So if you look at that, the first bit is the layout, split layout. We're using the string serializer, which is the first kind of serializer. So bit is 0. Then the third bit is for our compressor. There we're using the LZ4, and for encryption we don't have an encryptor yet, so we're using the null encryptor, right? And so bam, put that in, and we're good to go. Now, in the case specifically of Firebase, since it's a string store, we have to base64 the data, and then off we go, we send it. In the case of something like, so I put down a few of these with like Redis, you can just write the binary data directly, so you won't need that second last step of base64. You can just write the binary data directly. The same with JDBC and so forth. And one thing I did to simplify, the library was have a separate namespace where the actual interactions with Firebase happened, right? This made it a lot easier to read, and if you go check out the library, it actually is pretty straightforward to understand as a result. So there we go, right? So now there's only two keys, and that's the standard data and metadata, and there it is, encoded. Now, there is one pesky thing about Firebase that generally doesn't occur when using Firebase in a, let's say, a reasonable manner, that you hit the 1 megabyte limit for the data within a key, right? So basically what I need to do is make sure that if the data based on its length is more than 1 megabyte, we actually split it out into separate keys. I mean, in the case of Datahike, this generally isn't the case, but you never know, right? So what will happen is if there's a 4 megabyte value, to have P0, P1, P2, P3, and then when you read from it, it just combines them and then does the decrypt, decompress, deserialize, voila. So there we go, right? And so here's an example of what konserve looks like in an application. So this is the Firestore. There's a new Firestore, and you can put it out, and that Google application credentials is the environment variable that has the service account details, right? And then the root way in the JSON tree, what the name is. And this is pretty neat because of this you can actually have, konserve, I think konserve Fi is the default root, but if you have a multi-tenant application, you can actually have them in different roots, and that's pretty neat. And then you can see down at the bottom we have define the new type test, and we can actually write that to the store because of incognito under the hood, another replikativ library. You can actually serialize the type and then deserialize it successfully. Okay, so what did we get? We got konserve Fire, so Firebase backed, backend for konserve, and then we also, you can't just take, right? So you have to give back. So with my learnings and all these discussions I had with Christian and the folks at Lambda Forge, I figured, let's build a JDBC one, because from a Datahike perspective, the pure implementation has memory store and a file store. So at scale you probably want something a bit more battle hardened or maybe not battle hardened, but more fit for purpose than a file store. And so there was the JDBC one. Okay, and obviously we got to do Gameful. We got Firetomic. So that was super exciting. We finally made it. Our mission was complete, well, almost. We had to do a little bit of configuration still, and this is where Timo Kramer really helped. He's very active in building Datahike and now Datahike server as well. So basically I had to build a config that connects Datahike to the console store. And because of the way Datahike is laid out, this is actually very trivial to do. There's a few methods you have to implement, and you add specs to make sure that you validate the config before trying to interact with the store, which is particularly important with Firebase. Because it's a JSON store, if you do something dumb, you can just override all the data that you have in there. So you helped me, understand this, and I prefer Mali, and I'm not really into spec, so I just needed some guidance there, and then there we go. And then you'll see by default that the environment variable is null, because down the chain, in Fire, in Google credentials, if the environment variable is null, it looks for Google application credentials. This is just for convenience sake, and generally if you're in a Google environment, that variable is set with your credentials, right? And then we use a root as Datahike, but this can be overwritten if you want to have a multi-tenant application again. And so there we go, right? And that's it. We have our immutable database with the data log query engine running on Firebase, basically Firetomic. But let's actually look at it in action, right? So, so we have a REPL running here. I've loaded a few things in here so we don't have to search if you're ever watching me type one thing at a time. So we want to create the database, but before we do that, you can see here this is Firebase. So let's get the database. I'll store the config here, and it should create the database in a bit. There we go. So we can see I have named it, clojureD, see different namespace, and there's the data, right? No drama. And then the first thing we want to do is create a connection to that database. So again, right. Bling. So now it's connected, and then now I can actually transact. So the first thing I want to generally transact is our schema. This is basically the schema that you saw in that example code. So nothing fancy, but I've actually implemented it with real schemas. In reality, we actually ported from the startups I'm involved in. We're actually aiming to launch our DB now on Datahike Firebase in the upcoming month. So so we can see there's an update, and now the schema has been transacted. And so now maybe we want to add some real data. So let's add there you go, these 3 ladies and someone got a name who's 15 years old. Let's see, date writes to Firebase. And then if we query and we want to query an entity that has a name and has an age, right? And there we go, Anastasia, Cecilia, and Agatha. But let's say we wanted to just count how many entities have both a name and an age. You count, and that was 3. So basically, importing our DB from pure Firebase to Datahike, basically uses the Datomic docs and zero drama. Okay, and then maybe want to be a bit more experimental. So let's quickly do this and see what happens if we write a whole bunch of people to database, And so let's just create that, and then we want to vec what. So we'll take peeps, and we will, no, let's do it this way. Right, we will repeat. Let's get 1,000 people. Maybe 10,000. Let's live a little. And then we want to flatten that. Then we want to make a vector. Right. Then what do you want to do? We want to transact 40,000 people. Transact on our connection. We want to write lots of folks. Obviously, it's going to, take a while. But you can see, it's not particularly complicated data, but it's writing, and you can't hear it now, but my laptop is getting a bit warm. And there we go, and you can see the konserve keys being created. And then we've added 40,000 entities, and maybe let's count the ones who have names, like we did before. And it will also take a while. But you see, the nice thing is here that there's a garbage collect and there's caching. So we'll see our first count, as you can see, is taking a while. And while it counts them, you can actually inspect the various keys. See, there's a whole bunch of them. And then the nice thing about using Firebase is that it actually has backups by default, right? So you can actually run these backups, and you can actually back up your data as you go. I wouldn't recommend keeping them for more than 30 days because I tried that, and after a few months the bull just runs away. But anyway, so here we have our data. And this count is taking a long time, longer than I thought. Okay, well, you get the idea. There's lots of stuff to count. Yeah, we'll come back to that. So there we have it, right? We got Firetomic running, no drama. And yeah, so I've had some bad ideas, bad ideas. We now have Kafka and Firebase and Datomic and Firebase. And the nice thing about this is that when it comes to prototyping, Firebase is a generous free tier, so you can actually prototype many different things on the same Firebase instance. And this is important if you're helping small businesses and startups who want to validate the idea without incurring too much cost, or if they don't have any money. So you may ask, what's next for this illustrious Firebase fanboy? But before I tell you, let's see if we've counted our things. No, we haven't. So I saw an article the other day in my Google newsfeed that spoke to, someone said that a DNS is basically just a really fast key value store. And it got me thinking, and I won't make any promises, but maybe we could have Datahike on the DNS. Who knows? Yeah. But no, seriously, here's some useful links. So check out the Datahike repo, join the Discord. Folks, they are really, really helpful, really, really nice. We've had some good chats, doing some great work there. If you need commercial support, the Lambda Forge folks are always keen to help. They've helped me. And then the last two, there are some really nice videos. One about Datalog and one about hitchhiker trees. So hitchhiker trees are the underlying data structure that Datahike is built on. And if you find you have, some time on your hands, some passion in your heart, and you want to help out, bring a Datalog database that's open source to the world, click the green button. Oh, there we go. We have 30,000 entries that have a name and an age. And if it runs again, it's cached. Super nice, super nice. Yeah, that's all from me. It's been great chatting to you. Thank you for having me on clojureD. And I'll see you around.
Hello and welcome back, everyone. We're now at the Q&A with Alex. I hope you all enjoyed his talk. I saw some sorcery with DataScript and Datahike and combining it with all these interesting storage technologies. And we're now gonna take a look at some questions in the chat and have a little bit more of a discussion around his talk. So the very first question, Alex, is how did you learn to tell your stories in such a fantastic way?
I
remember that from last year too.
Yeah, I mean, I think it's because I lectured for a while. So straight after varsity, I was a lecturer, and I'm also like a heavy introvert. So, and a lot of my personality tests I got 100%. So I really had to learn the skill because it was
right.
thing, went it out. And then I also started watching a lot of these analyses of movies on YouTube, those video essays. Yeah. And then from that, you actually learn a lot of the style and stuff from that. And so, yeah, that's how the kind of came. Now it helps me in everything really. So yeah.
That's really cool. It's really cool. It's nice to see that, right? You felt like an introvert, and now you kind of looked at stuff and kind of found your way into essentially kind of putting that aside for a little while and really portraying or giving this kind of presentation that people really seem to enjoy and admire your style, right?
I do have to recharge afterwards. Even after conferences, I just spend 2 or 3 days just on my own writing code, listening to music.
Yeah, I definitely have that too. The post conference wind down kind of where you take a day for yourself. Yeah. So there was one person working for Rome Research, I believe, and they had a couple of questions around the Datahike Firebase integration because they also build on DataScript and Firebase. And so there's a couple of questions in that direction. And I guess let's just start from the top. And the first question I was asked is does Datahike and Firebase support multiple writers?
Yeah, so Datahike is, I think the transactor recently has come out or is about to be merged. But I think it's still one write, if I'm not mistaken. I don't think it's multiple writers yet. I would imagine you need to have some sort of queue to ensure the writes. Technically, Firebase does allow multiple writes with the transactions and stuff. But even though it does, if Datahike is not aware, it won't necessarily work out correctly. So at the moment, it's still one single read, single write. Yeah. But over the last 2 weeks, I've rewritten some of the Firebase integration to use a socket. I'm still testing that before putting it in Datahike Firebase, and I think with the sockets, it'll reduce the latency quite significantly. But at the moment, it's still REST.
Right.
Yeah. So I haven't. Yeah.
You would basically have kind of one transactor in a way, right? Like a server that you send requests and that talks to Datahike, which then stores the data in Firebase.
Yeah. So Datahike's transactors should be coming out quite soon. Yeah.
And then one other probably like kind of easy question maybe to answer is, what's the largest database you've stored in Datahike, or in this setup, basically, like not specifically Datahike, but like your kind of combination of Datahike and Firebase?
So I think at the moment it's not massive. It's like 130 megs.
Yeah.
But the thing I use Firebase a lot, but most of the time, by the time a thing gets to scale, I normally shift off. But there is a hard limit because Firebase maximum payload is 250 megs, right? So if you request data from Firebase that's more than 250 megs, it'll always fail.
Wait, like if the size of the entire database grows over 265 megabytes.
So the Firebase API has a maximum size, a single payload of 256 megs.
Oh, but a single payload, not the size of the entire data.
Yes. Sorry, the payload. So then you have to be a bit smart about pulling stuff.
Right.
Yeah. So, but I mean, it shouldn't be an issue with Datahike because you don't read the entire DP.
Yeah, exactly.
Yeah. But one thing that I found gets really expensive is if you put on daily backups.
Yeah.
They back up the whole thing and just a month later, even though there's 30-day recycle, it's too much data to leave on that. But because it's all JSON, you can store it on like S3 or on a much cheaper storage, so it's not really an issue to back up your stuff.
Right. Yeah, and there's also like Datahike backends even, right, for like S3 and stuff like that. So that's also like a whole different like field that we could get into of using these things for storage. One thing that I'm understanding that like all of the stuff you've built here is like built on the real-time database of Firebase, right?
Yeah.
And so Firebase has these two kind of database styles, I would say. One is a real-time database, which is more aimed at real-time use cases, as the name kind of indicates. And then there's Firestore, which, correct me if you disagree with that assessment, is more of a general purpose document database that's intended to scale more, like to scale to greater like overall database sizes and stuff like that. Would you say that's correct?
Yeah, that is true. Yeah. So initially I started off because I wrote a separate library called Charmander to be like a general interface to Firebase, based on the SDK, and I started off with the Firestore.
Yeah.
But the one limitation of the Firestore is the document size is maximum 1 meg.
Right.
That's like a hard limit.
Yeah.
So at least with the real-time database, its querying it actually does no querying really, to be honest. But with the Datahike layer on top, you don't need to worry about that anymore. So now you have, and I think the key value max size for the real-time database is 10 megs per key.
Right. You have like more storage per.
Yeah, because with 1 meg it means you basically can't store a binary in the DB. So then once I hit that limit, I just stopped using the Firestore.
Right. Yeah, that's interesting. It really, I guess in a way it's just not built for building and kind of a separate database on top, right? It's really like the way Firebase, I guess, designed this is like that. You use it as is. So let me take a look at the other questions here. I'm not sure. So there is a question about Firebase in general. And the question is, can you push down queries to Firebase, or do you download the data into the client and then do queries in memory? And specifically, I guess, in the data model that Datahike uses, which I think is kind of the same. The answer is probably the same, I think.
So Firebase, because it's in essence the JSON tree, you can only search at one point at a time. So the queries are very limited. So it does happen in the client. And at the moment, like the Datahike instance that I was speaking about now, and the one with Datahike is a client, anyway. So everything happens in memory. But there is a separate repo for Datahike server, right? Which then is like your MySQL server. Everything is in there, and like in MySQL, it also happens in memory. But then your actual application would have a client that connects to the server.
Yeah.
So then your application won't have the load. Yeah.
Yeah, I think that's the really interesting aspect about Datahike, right? Like that you can have this kind of, at least that's how I understand, like this parity, like a similar implementation of database on the client and on the server, and the boundaries get a little bit blurry.
Yeah.
And I mean, I'm not like super familiar with Datahike, but that's kind of, as I understand, like the end game of it, right? Like you have you do a database client, and like you basically don't think about, oh, there is a database somewhere on a server, and it's like just kind of same.
So at the moment, the team has actually done a lot of work, the konserve team, to have Datahike actually compiled to Clojure script, right?
Yeah.
So the end game is then you actually have, like, you can have it on a web client, on like an application server, and then your Datahike server. Then it really, you can even get to a peer-to-peer. I think the end game really is to have peer-to-peer.
Yeah. Yeah, or even that. Yeah, right. That's even more. Yeah, and peer-to-peer, that makes it, and like,
and the nice thing is, because it's like a data log DB, you can actually, run a query on the actual DB and give a person, multi users, you give the person their part of the DB for their client, and then it's like,
yeah. I'm still having like a little bit. So I like took a look at Datahike, I don't know, a couple of weeks ago maybe or so. And one thing, and I think after this question we might need to wrap up, but maybe we can talk about this for a minute. One thing I still find kind of isn't clear to me is stuff like permissioning, right? So authorization. With Firestore, you have this like model where you write some rules, and like if this field matches a field in your user record or something like that, you can do the write operation. And I'm kind of, from what I'm hearing, like that layer doesn't exist in Datahike. But then again, with the peer-to-peer nature, I wonder, like, how does that even work? Like, it's just a little mind bender for me, and I'm wondering if you can maybe like help me understand.
So I'm definitely not the resident expert on that, but I think what you generally see if you like search Datahike, the thing you get to is, in a way, the core engine, right? And what Datahike server is going to do, it'll give you that layer. Because when you think about like MySQL or Postgres, you're generally interacting with the Postgres server, right? And then it gives you the layer of permissions. So the Datahike server will provide that layer of different permissions.
That's so there is still a server that kind of has to do that. And I guess even in a peer-to-peer context, right, that could be the peer deciding if that's the other peer right to like this part of the database or something like that. That's really interesting. It's like just thinking about like databases that are peer-to-peer, right? It's such a different way of thinking around it. Like I find it like a little confusing, but just because it's different. But I think that's it, Alex.
Thank you.
Thank you so much for preparing your talk, for giving us this great presentation. And I hope to see you in person sometime soon. Maybe at the next clojureD sometime, or somewhere else in the world.
No, thanks for having me. It's been really good, and all the best to everyone. Enjoy the rest of the conference.
Thank you so much, Alex. See you around.
Okay. Cheers.